All right, welcome everybody to week 7, day 3. Today we're going to be learning about how to do files, file I/O, file input and output in C++. The good news is it is very, very close to what you know how to do already with cin and cout. In fact, once you've got your files open for reading and writing, all you have to do is change cout to be the name of the variable that you made that represents the file. And then you can just double left arrow into it, just like you double left arrow into cout. And you can double right arrow from it, just like you double right arrow from cin. So there's just like one extra line you have to do, which is, to tell C++ what file you're opening. So if I want to open a file called foo.txt, you have to tell it, open a file called foo.txt, and make a variable called blah. And then you can blah double right arrow to read from it, or blah double left arrow to write into it. Okay, so let's get over into the server and show you guys what that's going to look like. So So I moved the type alias up here, and I moved the size of the map up here just so that everybody uses the same size map. Got a print map here. I'm just curious why that. Oh yeah, because I moved the vector down here. Okay. There we go. Okay. So right now we've got a function to print the map to the screen, and let's say we want to do something very similar to printing it to the screen. But instead of printing it to the screen, we want to save it to a file. And we're going to save it to a file called map1.map, or we could call it map1.text. Like it doesn't really matter. Okay. So that means we're going to need a function that can do this. I'm calling the function before I write the function. And I do this a lot in C++ because a lot of times when I'm actually calling a function is like how I kind of know what I want it to look like when I'm using it. Right? When you write a function at first, sometimes you don't know, like, all right, should it be returning value? We're using call by reference. And so a lot of times I actually use the function first. Then naturally you can see it complaining at me. This thing doesn't exist, right? So I'm going to come up top here, and I'm just going to paste like this, just how I think the function should look like when I'm using it. And then I'm going to Shift V, select all this stuff, copy, and paste, and I'm going to rename it to be save map instead of print map. And then I'm going to look at this and make it match. Okay. And so save map is not returning a value, so it should be a void function. It's still taking a map by const reference. That looks fine to me, but I'm going to need to take a string. So this string will be like the file name. So that's the name of the file that we're going to write to. And do you guys remember the rules of thumb? We got 3 rules of thumb. Is this a primitive? Is it a non-primitive that's changing, or is it a non-primitive that's not changing? Based on that, should this be passed by value, like I have it right now? Should I pass it by reference, or should I pass it by const reference? What do you guys think? Vote now on Discord while I take a sip of delicious Cup of Joy latte. Yeah, so the file name itself is not going to change. We are going to be changing something, but it's not the file name. The file name is just going to get passed in, and it'd be really weird if, like, if we passed in the file name of like map1.text and it came back as like map2.text. That people would look at us like we're, doing something really wrong. So yeah, so this should be passed in by const reference. So all of this code here that has couts and things like that, like I said, it's just one change that needs to be made. You just need to change the cout to a new variable that is going to represent the file. Okay, so here is the learning point number 1 for today, which is like how to open a file for writing. In order to do this, you normally have to come up here and include fstream. But if your code is including my header file called read.h includes fstream. So you don't need to. If you're using read.h, if all you have is iostream, then yeah, you need to include fstream. And what include does is it copies and pastes that entire file into this file. So if you were to like have a file like hello.cc here, it's just like, you might look at this and be like, all right, this line is like 20, this file's like 23 lines of code, right? But with just these few header files included here, which I tend to include by default all the time, it'll go from 23, anyone want to guess? Anyone want to guess how many lines of code this is going to turn into? So we've got 23 lines of code here in this file. It's going to copy and paste everything in read.h. Read.h is about 100. And read.h includes iostream and fstream. And those are like pretty big. Then it's going to copy and paste everything from that into here and everything from algorithm into here. Anyone want to guess how many lines of code this 23 line of code file will turn into? G++-e hello.cc-e shows you what actually happens. So the preprocessor copies and pastes those entire files in. This is what it looks like when it's done. And this is going to go on for a while. 400 lines of code? 300 lines of code? I don't know. Let's pipe it through word count. You guys ready for this? So the -e again tells you after it's copied and pasted all the files in, and it's about ready to compile, and I'm going to pass it through word count by line, it is exactly 69,420 lines. How about that, huh? Isn't that amazing? So, yeah, it's just a weird coincidence. So, it is the world's most perfect Hello World program. I can tell you that right now. So we've got 23 lines here, and we got 69,397 lines included. So there's a reason why it takes a while to compile files. Like if we time G++ hello.cc, it takes 0.6 seconds, which is fast enough for me. But there's a reason why we don't just include everything, because then it starts slowing down your compiles. Now there's something called modules that are coming in. Technically, they came in C++ 20 2 years ago. They're still not ready yet in any of the major compilers. Visual Studio is almost ready. It's like almost ready for like the prime time. It's currently in like beta. G++ is currently slacking on it. Claying, who knows what's happening with Claying these days. So just because something enters the standard doesn't mean that the compilers immediately implement it. Some volunteer actually has to go and do the work. And the person who is working on modules apparently isn't anymore. So who knows when we're actually going to get it. But there's something called modules that, rather than all this hashtag include stuff, which is kind of garbage, you'll just be able to go import standard and just bring the entire standard library in. Someday, maybe next year, who knows? But not yet. So anyway, so what I was saying was, yeah, if you want to do any of this file stream stuff, you have to use fstream. Hashtag include fstream. Okay, but don't include things you're not using. If you're not using algorithm, don't include it. You know, it'll cut down on the number of lines of code. So if we take out algorithm from there, then you can see we just saved 16,000 lines of code. So don't include what you don't use. If we get rid of vector, that saves us 4,000 lines. If we cut this down to just include iostream, get rid of my read library stuff, that goes down to 44,000 lines. But iostream is kind of big, actually. It's 44,000 lines of code just in that. Okay, so coming back, nope, I can type it right, main.cc. Okay, so we're using vector, we're using colors. Okay. All right, so what we need to do is how to open a file for writing. And we do so by making a output file stream. That's the name of the type. We're gonna make a variable. And we're making a variable of type output file stream. And somebody give me a name for a variable that we're going to be writing to. John. Okay. So we're going to make ofstream John. Now, if we did ofstream John like to-do.txt or something like that, then this is going to open a file in our local directory called to-do.txt for writing. And if the file exists, it is truncated means erase basically, and set to 0 size. If the file doesn't exist, it is created. Okay, so don't do this with your to-do.txt or anything important. Some people, will do this. Like, I'll just try opening up main.cc for writing. And then they compile their code and they run it, and then their main.cc is gone. That's self-eating. It's like Ouroboros, the snake that eats its own tail. Right? So, if you could output code in your main.cc that you write out, then I don't know, it's a really bad idea. Don't do this. So we're gonna open a file by the name of file name. So whichever file name they pass in, down here you can see it's called map1.txt. Then that is the file that's going to be opened. Okay, and now we're good to go. Okay, so all we have to do is every place where you see cout, we replace that with John. Okay, that's it. Okay, and now instead of all of that stuff going to the screen, all that stuff will go to a file. That's it. That's how easy it is. So file IO using fstreams is very, very simple. So so I'm going to print map1, and I'm going to save map1. So g++ main.cc. Let me remove all the files. I got a lot of files in here from last class. Okay, so I'm going to run the code, and then it prints it to the screen. And then if you vim map1.txt, you'll see they got saved to a file. Now, what's all that garbage in there? All that garbage in there are the colors. Okay, so that's actually what the colors look like. Those are VT100 escape sequences. Probably not VT100. Probably a more recent standard than VT100. Whatever. They're special characters. So we should probably take that out. We should probably take out all those special characters so that it looks normal. So we get rid of all the reds and the greens and the yellows and the cyans and the resets. And probably the spaces too. Actually, we don't need a space. Just do this. Okay. Run it. And then we cat map1.txt and map1 is map. Okay. Sure. Okay, fine. Maps 1. Okay. Let's make them the same map this time. All right, run it, and then cat. And so you can see it's the exact same thing. So here we're doing colors and we're spacing everything out a little bit so it looks a little bit nicer for humans. This is the actual file, but you can see it's literally the same data. And all that data, if you vim map1.txt, you can see all that data, instead of going to the screen, it goes into a file. It's exactly the same code. That's it. That's all it takes to do files in C++. Yeah, it's not bad to write. At least we should do reading in a second. Couple caveats. So, what if you can't open the file for writing? That's something you need to check for. So, do you guys remember how we used to do like if not cn, and not just used to, but you should still be doing if not cn to see if like an error occurred? You guys remember that? Every time you read from a keyboard, you should check to see if an error occurred. The same thing is going to happen here. So every time you open a file for writing, you need to see if it was successful. Because maybe you don't have write privileges on the file, right? Like maybe it's owned by somebody else. Maybe, you're in a directory that's not your own, something like that. So you have to say if not John, cout error, couldn't open file name for writing. And then we'll just bail out. Okay, so every time you open a file, you should do that. That's just good practice. You might be like, well, I'm always going to write in a directory that I have write permission. Yeah, okay. Well, what if the hard drive's full? What if the hard drive's full? What if the file system is currently dying, which happens sometimes? What if you run it on a USB drive and then somebody yanks the USB drive out and it doesn't exist anymore? You really don't want to just continue on with your life not knowing that the drive that you were on is gone, right? And so good practice is every time you create a file, you should immediately check to see if it actually succeeded, okay? And the same is going to happen when you're reading from a file. And reading from a file can actually have a few different other ways of having errors. So it's even more important when you read a file than when you write a file. Some people do this. John.close. This closes a file. You actually don't need to put it there. When John goes away here at that close curly brace. It closes the file automatically. You don't have to do it. Some people do it because they consider it good practice. You don't need to. The destructor on John will close the file for you automatically. The only time I do this, so like, you know, if I've got a big function that's kind of like running forever, then John won't ever close itself. And then you've just got like an open file. And so if I have a situation like that, yeah, I'll deliberately just call close. Okay, I'm done with it. Because as long as John's open, then like nobody else can like read from that file and stuff like that. So if you have something where like John's gonna be sticking around open for like a million years and you're not using it, you should probably close it. But in a circumstance like this, where you just dump the map and quit out of the function, you don't need to do this. Whenever John leaves scope, it closes itself. But it's there if you need it. All right, so that is how to save a file. Let's look into how to read a file. Okay. So, and this might be very useful for your, you know what I mean? Like for your RPG assignment, right? You can actually have a text file that contains your map. So rather than you needing to recompile your code every time you change your map, which is kind of annoying, right? You can actually just have a map on disk, and then every time you run your game, it just loads the map. And you can edit the map and don't have to recompile every time. It's nice. This is how actual game development takes place. You don't recompile your code usually when somebody moves a power up around on a level. Like that's just part of the map file. It's not part of the code. So let's say I'm going to edit this and put a, I don't know, like the letter Q here, and I don't know what this represents. The character. So what I can do is main.cc. So I've got map 1, I've got map 2. Let's say I'm going to make map 3. Okay. Oh yeah, this is something. If you want to fill a map with something other than zeros, it's like if you do this, it's going to be 100 zeros. But if you give it a second parameter, then it's going to be 100 fives. So little side note there. If you want to make everything in a map the same value, you can pass it to the constructor like that. Okay, so now we're going to make map 3. And map 3 is going to be equal to load map map1.text. And then our atlas. Okay, so what we can do is map 1. Let's not call it map 1. Let's call it map 3. We'll just ignore them. We'll ignore the other two maps for now. Okay. Okay. So this function doesn't exist yet, which is why it's yelling at us. But this workflow, I want you guys to look at for a second. So when we launch the program, it's going to load the map from disk. And then when we quit the program, it's going to save the map to disk. And so you can like load a map and then like have the characters walking around and doing stuff. And then if you like need to quit in the middle of the game, it'll just save it to disk. And the next time you launch the game, the changes will be there. So it's a save system. Okay. So we're going to load it from disk and then print it to the screen, and then we're going to save it again. Okay. Without making any changes, but presumably in the meantime, the character is going to walk around and stuff like that. So I'm going to move map1.text, map3.text. Okay. So basically map 1 is going to be this randomly generated world. Map 2 is going to be this hard-coded world. And then map 3, it's going to load from disk. We're then presumably going to like, play the game. And then when we're done, we will save it to disk. And then it'll update over time. Every time you play the game, it'll reflect the changes. All right. So we need a load map. Okay, so again, this is kind of what I want my usage to look like. So I'm going to come up top here, and I'm just going to paste this so I know kind of like what I'm aiming for. All right. If you guys remember, map_t is something I made last time, which is just a type alias for vector of chars. So basically, anytime you see map_t, map type, that is exactly the same thing as if I typed vector of chars. And anytime you see vector of chars, I could type map type, and they're completely equivalent. I could use them interchangeably. The reason why I do this is just to make the types look a little bit nicer here, right? So each map is basically a 2D array of like characters, and I don't have to repeat that over and over again here. And then here, this const vector char ampersand, I could do that as auto to make that a little bit more compact as well. Thank you, auto as well. If I wanted auto and char, both 4 letters. Okay, so I'm going to need a load map function. Okay, so help me out here. This is what I want it to look like. So again, down here in main, I use the function because that kind of gives me an idea of like what I kind of want it to look like. And then I'm going to now write the function. And so you're going to have to help me out. What should the return type of this function be? Should it be void load map? Does that look correct to you? What type should be returned by this load map function based on how I'm using it down below in main? What do you think? What type should it be returning? Nope, not a string. It's taking a string as a parameter. Technically, this is a constant char start, but it's taking a string as a parameter. What's its return type? What kind of value should it be passing back from the function? Remember, functions take inputs in their parameter list, they do some computations, and then they return something in their return type. Nothing? Nope, it's clearly returning something. If this was a void function, we couldn't do this. So it can't be void. Vector, chars, variable, nothing. No, all you guys are wrong. This should be returning a map. Okay. And then what should the parameter be? What do you think? Nothing? What do you think? What should the parameter list look like? I'll give you a hint. It's pretty close to what we have up top here. Another map? Nope, it does not take a map as a parameter. So a map, remember, a map is a 2D array, a 2D vector. It is not taking a map as a parameter. What is this? What is that? It's a string. Good. So it's going to take string file name as a parameter. And if you remember the rule of thumbs, should we pass in this file name by value like this? Should we pass it in by reference if we're going to change the file name? Or should we pass it in by const reference if we're not going to change the file name? What do you guys think? We have 1 vote for reference. And the file name is this. I'm not talking about the file. I'm talking about the file name. Is this string going to change back in main? Down here, are we going to modify this string right here? Nope, we're not. So this is going to be a const string reference. Okay, now, very similar to how we write to a file using an O stream, we're going to read from a file using an I stream. O stands for output. I stands for input. So we're going to use an IF stream, an input file stream. Okay. Const reference. Very good. Okay. So give me another variable name. The hardest thing in computer science. So we're going to make an IF stream named. Give me something. I typically call mine ends or something. Lemon. Okay. So we're going to make fstream lemon, and the file that we're going to open is file name. And so that's probably going to be like map3 or something like that. So this is the learning point, okay? So learning point number 2, how to open a file for reading. Looks very similar, right? The file for writing uses an output file stream. The file for reading uses an input file stream. Otherwise, exactly the same. What does this do? It makes a variable named lemon of type input file stream. And what does it open? What file does it open? File name. Whatever value is in file name is the name of the file that gets opened, which is going to be map3.txt. And that's why I like copying and pasting my usage down in main up here, so that I can kind of, keep everything kind of straight in my head, right? So it's going to take a string as a parameter. It's going to return a map. You can see that it's returning a map right there. Name of the function is load map. It just works out really nice. It's a great little cheat sheet for designing a function. I just copy and paste how I use it, and I use it before I write it. So I kind of know what it should look like. All right, so we got a file named lemon here. And let's just do a little example, char ch lemon into ch, and we'll cout ch, and then we're going to quit the program. So we're just going to open up, oh, actually this is going to erase the whole thing, isn't it? No, it'll be fine. It'll be fine. It's not going to erase the file. If we did this halfway through fstream, it would be truncated, but we're doing it through the ifstream, so it'll be fine. Okay, so this is going to read just the first character from map3.txt. Okay, so if you remember what map3.txt, this should give us a asterisk. You guys understand? So this is going to open the file map3.txt for reading, and then it's going to read. Notice instead of cn, instead of reading from the keyboard, we're going to read from a file instead. And it's going to read one character out of the file, which is going to be an asterisk. I'll just give you guys that one for free. It's going to print the asterisk to the screen, and then it's going to quit the program entirely. Okay. There you go. Okay. Now, let's say that our map3.txt had some spaces in it. And I do this again. Is this going to give me a space or an asterisk? A little bit of C++ trivia here. We put an asterisk or a space into the character. What do you think? Vote now. Operators are standing by. Reading from a file. The file contains asterisk, space, 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 asterisk, asterisk. We have 4 votes for space. We got 1 vote for star, another vote for space, another vote for star. We got 21 people on the stream, and we got 8 votes so far. So, you want me to start naming names? You should all vote. Good. It's 50-50, right? So, a lot of students are like afraid that they're going to guess and get it wrong. It's like, no, that's the whole point. Like, you learn, like, when you're like, oh, it's going to be I'm not going to tell you the answer yet. But, yeah, like, if you were to say, oh, it's a space, and it turns out to be a star, then you remember it more, okay? Because you've staked your ego on it. The professor knows that I don't know. Yeah, I know you don't know. That's why you're taking this class, right? You're not supposed to know anything in this class, okay? And we got a star. Why do we get a star? Why do we not get a space? Double right arrow skips white space, right? Do you remember that? Like when you're typing in like hello and you put a bunch of spaces in world. If you like see that into 2 different strings, you get hello on the first one and world on the second one. Double right arrow skips white space by default. So if you wanted to get the actual characters, including white space, you got to use a slightly different thing, okay? There's something called get, okay? And so get returns 1 character, including white space. Now, for double right arrow, there is an option. You can actually do like cn no skip ws. Like you can do this to turn off white space skipping. That's an option too. But I like using git. So git will just give you the next character out of the file or out of. You can use this with cn also. It works with everything. There's kind of 3 options for doing input in C++. There's getting a character at a time, which is this. Getting a word at a time with double right arrow. There's getting a line at a time with get line. So there's different levels of fine-grained inputness that you can handle. So this is just going to get 1 character. Okay, and we're going to print it at the screen, and then we'll do the same here. And now, when we run it, we will get an asterisk and we will get a space. You guys see the difference? Between double right arrow and git. Git is a function, double right arrow is not a function. It's somewhat frustrating to me. I think all input in C++ should be functional. I don't like the double right arrow syntax, like in general. You can chain together things nicely, but in general, every time you read something in, you want to error check it. And so I don't chain together input usually at all, almost. Okay, so yeah, .git will give you the next character. Now, here's a question. What happens if there's no characters left? Okay, so let me move map3.text to map4.text, then map3.text. And I'm just going to put in a queue here and nothing left. Okay, I don't need to recompile our code, by the way. Do you see that? I'm not recompiling the code. All right. This is why, map editors exist. You can edit your map without having to recompile your code because my program's still the same. It's reading the first 2 characters out of the file. So this might be a little subtle for you guys, but do you see there's 3 lines of output here and there's 2 lines of output here. So what was the second character that got read? Well, maybe we can do this. On error. I think it's reading a new line character is what's happening here. So let's do this one more time. And an error occurred. Okay. So if you try reading off the edge of a file, then do you remember how, like, whenever you do a cn, you should always say if not cn, right? Same thing, right? So every time you open a file, you should immediately check to see if not lemon in this case, right? And that means I could not open the file name for reading. So if the file doesn't exist, it will give you an error. And then you can, either handle it or quit the program or whatever. But then every time you read from a file, you should always do this, right? You should always check to see if an error occurred so that you know that you've gone off the edge of the file. Now, you don't have to quit necessarily, right? But you want to know when you've reached the end of the file because otherwise you're going to keep reading forever. You know what I mean? Like, when do you quit reading? Well, when you got to the end of the file. How do you know when you got to the end of the file? You tried reading something and it didn't exist. This is how you check for end of file. So it's actually not an error. It just means end of file reached. Okay. So, and then, yeah, here's the end of file character right there. So, do you guys understand? Let me do this in a full thing. So let me move map 4 back to map 3, and then let's do a full-on map reading loop now. Okay, now that we know how this works. So, how to open the reading. Okay. So we're gonna do the whole thing now. So, okay, so we're gonna make a map to return it, right? And this map I think we defined all of our maps to be 10 by 10. So I'm just going to copy and paste this here and call this return value. So that's the map we're going to return. Right now it's completely blank. So what I'm going to do is say for every row in the map, for every column in the map, read from the file into the map. And I can do this using a range-based for loop. So for auto ampersand row, so for every row in retval, for every column in retval, and these are not const reference, they're not value, they are call by reference. Why do these things, that should be row there, thank you. Why do these things need to be reference? And then I'm going to return retval. So why do these things need to be non-const? They need to be just a regular call by reference parameter. Why? Why? Because I'm changing it, right? So I just made this giant 10 by 10 map. Well, it's not giant. I made a 10 by 10 map, completely blank. But what I'm going to be doing is I'm going to be reading one character at a time from the file and putting it into the map in the corresponding spot. So for every row, for every column, I'm going to be getting each of the values out of the file. Now, this is not going to work, but it's going to be funny, so I'm going to do it. All right. So I am loading the map, and then I'm going to print the map, and then I'm going to save the map. I don't want to save the map. I don't want to mess it up. Okay. So go in here. This is what I'm loading. So there's actually two problems that are going on here. So the first problem you might be able to see. I'm loading into a 10 by 10 map, and how many characters are on the first row? Do I have 10 or do I have more? I got more. So what's going to happen is the first asterisk there is going to go into the first row, the first column. The space here is going to go to the first row, second column. First row, third column. First row, fourth column. Fifth, sixth, seventh, eighth, ninth. Now, we move on to the next column in the map. And that one is going to go into column 2, row 1. Column 2, row 2. Column 2, row 3. Column 2, row 4. Okay? So this guy over here is actually not column 2, row 1. It's like column 2, row 5 or 6 or whatever. I lost count. Right? So you got to make sure that all this stuff actually has 10 by 10. If you're going to be reading into a hard-coded 10 by 10 map, then you need to make sure your file has 10 by 10 or everything gets screwed up. All right, now it's 10 by 10. It should be fine now, right? What's going on here? The heck? Yes, very good. It is reading the new line at the end of the line. So the new line character, like I kind of hinted at before, is a character. And so it's going to, and it's not skipping white space, remember? So it's reading every character, and then it reads the new line, and it's putting the new line in the first row of the, the first column of the second row. So that whole row there is now just a new line character. When it does all this, then it's going to read another new line. So we need to skip all the new lines, okay? And so we need to do that by save load. Okay. So we're going to get that, and then we can say if it's a new line character, then just do it again. And that should work. Okay. And if we really want to be careful, maybe we could do a while, maybe. But I don't think we've got double new lines. So this should be fine. It should be fine. Okay. And there we go. So what are we doing here? Well, we read a character. We don't skip white space anymore. So we read a character and we get the new line character. We're like, all right, that's cool. Throw it away. Do the next one. Okay. So basically, every time you read a new line character, it just basically gets thrown away and the next character is read. Now, if that one was also a new line, we're in trouble. But, you know, I don't care enough to do better. The correct way maybe of loading a map is to not hard-code in your size and to figure out how many characters are on each row and resize the map properly. But, you know, it's a school project. It's not like I'm working for Microsoft. So this is good enough. And so there you go. That's actually a functioning map loader, right? And so if we load this map, and then we do something like we're going to load the map, we're going to print it, and we're going to change maybe maps to 1 is equal to x. Let's see if that works. So map 2, row 1, column 1 is now set to x. And then if we check map 3, you can see it's now in the file. And so whichever bits of code we write that actually modify the map get reflected in the save. So the next time we load it, the x is going to be in there. And then we can change the map further and then save it and then load it the next time. And then, you guys understand? Like, this is how like actual software works. Like, actual software very rarely inputs lots of data from the keyboard and writes to PuTTY, you know, like who uses PuTTY, right? You know, for like, you know, actual, you know, commercial software. Like, everyone's got a graphical user interface. But what they do use is reading and writing into files, right? And so it's very common to load a file, make some changes, save it. Right? Yeah. You play a game, you load the map, you pick up a health box, you save it, health box isn't there anymore. So the next time you play the game, the thing's gone. Okay? So that is basically the lecture for today. The one thing you need to look out for, again, is every time you do a read like this, you need to say if not lemon break. Right? We're done. Yeah, probably here too, right? Every time you do a get. Every time you do input, you need to check to see if an error occurred. Because the most common error you're going to encounter is you've hit the end of the file. Right? In this case, we know exactly how many characters are in the file and how many characters are in the map, and so no error is going to occur because it's all kind of like hard-coded. But in real life, somebody could come in and just like, you know, they could just come into like the map file and just like start deleting lines out of it. And so your code would fill the map with corrupted data because it's going to read off the end of the file and it's going to be like end of file, end of file, end of file, you know, and you're like going to be filling your map with end of file characters, which is really bad. So you need to detect this, right? So in the case where like this shouldn't happen, you might actually just, you know, die, right? Like you might actually just print an error, and you might actually just print an error and kill the program because your map on disk has to be 100 characters exactly, because your map in the game is exactly 100 characters. So you might actually just throw a fatal error and like you do something like this, like assert lemon. And so, you know, no errors should occur during this because we know in advance exactly how many characters there are. Usually you don't know that though. So usually you just keep reading. This will kill your program if lemon is false. Okay, that's what an assert does. An assert will just kill your program, and that's a very simple, very easy way. In practice, you'd probably want to handle it more gracefully. If not lemon, print to the screen, error occurred while reading the file. Make sure that your file is big enough. Like in practice, you probably want to have a nice error message. But if you just are lazy, you don't want to be so lazy that errors could occur and you don't notice, and then it loads in all this corrupted data. Then when you quit, it saves it into the map and corrupts your map file, because that's the kind of thing that really annoys people. Like, people don't mind so much when your code crashes. They do mind when the code crashes and they lose 100 hours of gameplay. That will make them never play your game again, make them an enemy for life. They will post hundreds of negative reviews using 100 different false accounts on Steam, bashing on your game because you wiped out their 100-hour save game. Okay, so rather than doing that, just if you're going to be lazy, at least be lazy correctly. Slap an assert on there. The asserts are used when something like really shouldn't happen. But if it does happen, like if lemon becomes false unexpectedly, like somebody's like, like you're loading it off of the thumb drive and somebody yanks the thumb drive, like the assert will catch that and it'll kill your program immediately. It'll say assert failed, line 68 on main.cc, lemon is false. And so, sure, it's not the most informative error message ever, but it'll keep you from like working with corrupted data, which is really bad. So just get always into the practice of doing this kind of stuff, right? Like always, always. Every time you do a read, always with a read, check for an error. Okay. In this case, we'll just break, but like I said, because we know it's a 10 by 10, like we could actually kill the program, or we could do an assert or something like that. That's probably the better way of doing it, and actually like kill the program, or you could break, either way. Okay, so that is that. I'm gonna make sure that all works. Okay, everything's fine. So there you go. So we can load a map, modify it, save the map, and that means it is lab time. So you guys got an hour. Work on your projects in your groups. I'll be here. I'm going to stop streaming now because in the previous class I was just playing like meme music, Druid Sandstorm, What the Fox Say, Nickelback Photograph, Barbie Girl, I'm Blue, Dabba-dee, Dabba-doo, that kind of stuff. Kind of trolling my students, because that's the main reason why I teach. But the importance of files, like you need to be able to read and write to a file. Like think about it. Every time you do any program ever, you're almost always going to be loading data from disk and saving data to disk, and that's how you do it. So, if you and Mint Corelli is here too. Yeah, hit up Mint Corelli. Like, let me just fire up Microsoft Word, right? So, here's a blank Word file, and I'm gonna type my beautiful essay, right? And when I hit save, that gets written to disk. I just taught you how to do that. Okay. The code that we learned today allows you to write a file to disk. And then later on, I can launch Microsoft Word and load it back off disk. So for your role-playing game, yeah, loading and saving maps is the obvious thing. We could also load your character's name, health, things like that. So you can, like, if you're playing a game, like a big role-playing game, like, you usually can't beat it in one sitting, right? So you can like save and quit, right? And then you can come back in later. So this is how you can save anything you want to disk. This is a very, like, it's not just for the RPG assignment. Reading and writing to disk is like the thing we do. Like I said, we very rarely input lots of data from a keyboard or from the screen. We do that in this class just because it's the easiest way of doing data entry and output. But in practice, it's all to and from files mostly. Yeah, and then like if you save the character to disk, then the user can come in and edit the file so they have 9,000 health or whatever. So does that make sense, Raphael? Yeah, file. Yeah, it's really important. Like this, it's way more common than CN and Cout. Let me tell you that. Way more common in real life. But as you can see, it's what, like one line of code different. So rather than using like cn.get, which would give you one character from the keyboard, it's just lemon.get. And rather than like writing to cout, right? Like our code up here writes to cout. It's just you write to John. Write to John. Right? It's literally the same code. It's the exact same code. It's just you just choose. Like, do I want the end line to go to the screen, or do I want the end line to go to the file? And the file, the variable name for the file is called John. For I don't know why you guys picked John, but you did. So there you go. So we made a output file stream named John that is connected to this file, whatever file that is, file.txt or whatever. And so this is a variable named John, and then everything you write to John goes into that file. It's very simple. Everything you do with the file is almost identical. It's just that one, you just change C out to John. That's it. Okay. Let's go on, Bencourt. Yeah, Bencourt, if you want to talk after this during a laptop. So yeah, that's it. So lab time begins now. I'm going to stop streaming. If you have any questions, message me, message Ben Crowley. Remember, sea shanties are coming up on Tuesday. And we're also going to be talking about the ACM, which is the Computer Science Club on campus. So if you're interested in joining the Computer Science Club, make sure you come to Sea Shanty Night, because it's a dual-purpose workshop for both learning how to do work songs. If the whole computer science thing doesn't work out for you, you can always get a job on a tall ship, hauling on the lines and raising the yards and things like that by singing sea shanties. So, all right, that's it. Peace, everyone. Lab time begins now.